Hello everyone, I welcome you all for today's video session in the topic process scheduling from the second unit process management in the course CS 3451 Introduction to Operating System. Myself, Dr. C. Rani. Now let's see the objective of today's session is to know about the basic concepts of process scheduling. And the outcome of this session, the students may be able to understand the basic concepts of processes scheduling. Here is the outline of this video session. That is, first we'll be discussing about what is meant by scheduling, what are the importance of process scheduling, and what are the two types of process scheduling, that is multi-programming scheduling and time-sharing scheduling. Next, we'll see about the scheduling queues. There are three types of queues. First one is job queues, ready queues, device queues. And next, we'll be seeing about the schedulers. There are three types of schedulers are available. First one is short-term schedulers. Second one is long-term scheduler. And the third one is medium-term schedulers. Next, we'll be seeing about the comparison among the schedulers. And the final one, we are going to see the context switch technique. So here, the scheduling is nothing but the process of assigning the resources to perform the task. The resources means we need to have a look over the processor's utilization time, network links, expansion costs, etc. And the task may be the threads, processes, flows, or data flows. The scheduler's responsibility is to do the scheduling activity by the process. Okay, the schedulers are often designed. So the schedulers will be keeping always the computer resources in a busy manner, or in other words, we can say they will be taking the responsibility of balancing the load, which allows the multiple users to share the system resources in an effective manner or to achieve the target quality of service. This scheduling is fundamental to the computation process, and it is a part of the execution model of the computer system also. So the concept of scheduling, which makes it possible to have the computer multitasking with a single central processing unit. So the process scheduling is the activity of the scheduler or the process management, which has the task or that will handle the removal of the running process from the CPU and the selection of another process on the basis of particular strategy. Okay. So the process scheduling is an essential part of the multi-programming operating system. Such multi-programming operating system allow more than one process need to be loaded into the executable memory at a time. And the loaded process will be sharing the CPU using the time multiplexing concept. Okay. So let's see what is the importance of process scheduling in operating system. So the process scheduling will allow the operating system to allocate the CPU time for each and every process. So the another important reason to use the process scheduling system is that it will keep always the CPU in a busy manner at all the times. So this will get the less response time for the programs. Here you can see the two types of operating system are there. The first one is multi-programming operating system. The second one is time-sharing operating system. When coming to the multi-programming operating system, more number of jobs, job 1, 2, 3, more number of jobs will be executed simultaneously by the operating system. That means the job means otherwise called as process. So all the process will be loaded into the main memory and the CPU will execute all the process simultaneously. Hence, it is called as multi-programming operating system. Okay. So the objective of the multi-programming is to have some process running at all the times in order to maximize the CPU utilization. Okay. When coming to the time sharing operating system, the CPU will frequently switch between the users for doing two things. One is multi-programming or time sharing. We require the process scheduler. So the objective of the time sharing is to switch the CPU among the processes so frequently. The user can interact with each program while it is running. So to meet out all these objectives of multi-programming operating system and the time sharing operating system, the process scheduler will select the available process to execute on the CPU. If there are more number of processes and the rest of the processes will wait until the CPU gets free. For example, when a user is running a Java program and another task, if she or he hear the music using the media player, and the third task, if we download the active software using the Chrome browser at the same time. If the user wants to do all these three tasks at the same time, some processing needs to be done. Okay. So what is meant by a scheduling queues? The scheduling queues are divided into three queues. One is job queue, ready queue, and device queue. So job queue means all the processes upon entering into the system that will be stored in the job queue. So the process which enters the system will be stored into the queue called job queue. And the processes which are in the ready state will be stored in the or placed in the ready queue. The processes which are waiting for the input output device to become available, that will be placed in the device queue. So there are unique device queues available for each input output device. A new process which is initially will be put in the ready queue. And it also waits in the ready queue until it is selected for the execution or dispatched. Okay, once the process gets assigned to the processor, the CPU, it will be executed in one of the following several events can occur. First, the process could issue an IO request. If the process issues an IO request, then the process will be placed in a input-output queue, that is IO queue. The second case, that is the process could create a new sub-process and wait for its termination. Here, the new sub-process means child process. The parent process will wait until the child process finishes its execution. The third case is the process could be removed from the processor, that is CPU, as a result of an interrupt. Whenever an interrupt occurs, the process will be removed from the processor and it will be again put back in the ready queue. So here you can see the queue header, that is the ready queue will be containing the queue header in which head and tail are there. The ready queue is generally stored as a linked list. Okay, the queue header will be containing pointers to the first PCB in the list and also to the last PCB in the list. PCB is process control block, and each PCB includes a pointer field that points to the next PCB in the ready queue. And here you can see there are two types of queues are present. One is the ready queue, the other the set of input output device queues is over there. Here the rectangle box represents the type of queues, and the circle represents the resources that serves the queues. The arrow represents the flow of process in the system. Here, whenever the process gets assigned, it will be stored in the ready queue. And the processor, if the process needs to carry over the IO request, it will be placed in the IO queue. Okay. When the processor, the time slice expired, it will move on to the ready queue. Okay. If the process creates a child process, that is sub-process, using the fork system call, the child will be executed. That is, the instructions of the child will be executed. So the parent will be waiting till the child process executes or completes its execution. Okay. The process will also wait whenever an interrupt occurs. Here you can see the new process is initially that will be stored in the ready queue. It waits until it is selected for the execution or dispatched. Once the process gets allocated and it is executing, one of the several events will occur. So as we have seen, issuing IO request, it will be placed in the IO queue, and creating the child process, and the parent process will be waiting until the child completes its execution. Or in other words, wait until the child termination. And the process CPU will can be removed. The process will be removed from the CPU as a result of the interrupt. So the three cases can occur. Next, we'll be seeing about what is meant by a scheduler. They are the special system software which handles the process scheduling in various ways. The main task or the responsibility of the scheduler is to select the job that is to be submitted to the system and decides which process to run. The schedulers are of three types: long-term schedulers, short-term scheduler, and medium-term scheduler. First, we'll see about the long-term scheduler. It is also called as job scheduler. So what is the task of a job scheduler? Will determine the programs, will determine which are all the programs are admitted to the system for processing. And it is also responsible for selecting the processes from the queues and load the processes into the memory for execution. Whenever the process loads into the memory for CPU scheduling, the primary objective of the job scheduler is to provide a balanced mix of processes or jobs such as IO bound and processor bound. So the long-term scheduler also controls the degree of multiprogramming. If the degree of multiprogramming is stable, then the average rate of process creation must be equal to the average departure rate of processes leaving the system. On some system, the long-term scheduler may not be available or minimal. The time-sharing operating system have no long-term scheduler. This is an important point to be noted. Time-sharing operating system will have no long-term scheduler. When a process changes its states from new to ready, then there will be the usage of long-term scheduler. Next, we'll see about the next type. Short-term scheduler is also called as CPU scheduler. The objective of this CPU scheduler is to increase the system performance in accordance with the chosen set of criteria. So it is the change of ready state to the running state of the process, and the CPU scheduler will select the process among the processes that are ready to execute, and the next task is to allocate the CPU to one of the process. The short-term scheduler is also called as dispatchers, which will make the decision of which process to execute the next. So short-term schedulers are faster than the long-term schedulers. Next, we'll see about the medium-term scheduling. It is a part of swapping. So what is the task of a medium-term scheduler? Which will remove the process from the memory, which the term it is termed as memory swapped out. Next, it also reduces the degree of multi-programming. So the medium-term scheduler is in charge of handling the swapped out processes. So the running process may become suspended if it makes a IO request. So the suspended process cannot make any progress towards completion. In this condition, to remove the process from the memory and to make space for the other processes, the suspended processes move to the secondary storage device. So this process is called as swapping. We called medium-term scheduling is a part of swapping. Okay, so medium-term scheduling means it has the role of swapped in and swapped out process. So the process is said to be swapped out or rolled out. That is, it removes the process from the memory means we call that as a swapped out process. So swapping may be necessary to improve the process mix. Next, we'll have the discussion about the comparing the three types of scheduler. Long-term scheduler is also called as job scheduler. Short-term scheduler is also called as CPU scheduler, whereas medium-term scheduler is a process swapping scheduler. The speed of the long-term scheduler is lesser than the short-term scheduler. The speed of the short-term scheduler is fastest among the other two types, long-term and medium-term scheduler. The speed is between both the short-term. The speed of the medium-term scheduler is between both the short-term and the long-term scheduler. Long-term scheduler controls the degree of multi-programming, whereas short-term scheduler provides lesser control over the degree of multi-programming. Medium-term scheduler reduces the degree of multi-programming. Long-term scheduler is almost absent in time-sharing operating system, whereas short-term scheduler is minimal in time-sharing operating system. Medium-term scheduler is a part of time-sharing operating system. Long-term scheduler selects the processes from the pool and loads them into the memory for execution. Short-term scheduler selects those processes which are ready to execute. Medium-term scheduler can reintroduce the process into the memory and execution can be continued. There are two types of scheduling. One is preemptive scheduling, the other one is non-preemptive scheduling. Preemptive scheduling means it is prioritized. The process will be prioritized. The process which has the highest priority will be executed first. Okay. Non-preemptive scheduling, when a process enters the state of running, the state of that process is not deleted from the scheduling until it finishes its service time. So non-preemptive scheduling may be of switching from running to waiting state, running to ready state, waiting to ready states, process terminates, while the others are preemptive scheduling. And next, we'll see about the context switch technique. So it is the mechanism to store the state of the process and restoring the state of the process or the context of a CPU in process control block so that the process execution can be resumed from the same point after a long time or at a later time. So using this context switching technique, the context switcher enables the multiple number of processes to share a single CPU. So context switching is an essential part of the multitasking operating system features. So when the scheduler switches the CPU from executing one process to execute another, the state from the current running process is stored or saved in the process control block. After this, the state for the process to run next is loaded from its own PCB and used to set the program counter registers value. At that point, the second process can start executing. That is, you can see here, two processes are there, P1 and P2. Okay. So when the two processes are set to be run, the process P1 state will be saved in the process control block. So in the meanwhile, process P2 will be start executing. Whenever it wants to continue with the process P1, the stored P1 state will be resumed, and whatever the state P1 process P1 state, that information will be stored in the PCB. So it can be retrieved back, and we can move on to execute the next process also. So in this manner, we can store the process state, any process state, and we can also restore the same status after a long time or at the later time. This process is called as context switch technique, which will maximize the CPU utilization. Context switches are computationally intensive since register state and memory state will be saved and restored back. To avoid the amount of context switching time, some hardware system employ two or more sets of process registers. When the process is switched, the following information will be stored in the process control block for later use. So what all the information will be stored in the process control block? The process control block will maintain the following information, that is program counter information, scheduling information, base register value and limit register value, and currently used register information, and what are all the state information, what are all the state of the process which changed state information, IO state information, accounting information. All these information will be stored in the process control block. These are the references used for preparing this video lecture. Thanks for watching. Thank you.